Hi class, it's Bill Berry with another video, this time one on functions. We're going to do a couple of videos to talk about this. This is a super important concept that we're going to be covering for a couple of weeks. It is one of the fundamental concepts without which we can never write programs of any substance, and without which we end up writing a whole bunch of duplicated code. They are just a very important building block for us to understand, and this is true in JavaScript as well as other languages. They're just something that you've got to know about and got to have facility with if you're going to write your own code or modify code that you see elsewhere. So super important topic next 2 weeks. Let's jump in and look at what we're going to do this time. First thing that we're going to do is talk about an analogy that I'm going to call the lazy professor. And we're going to use that as a springboard to understanding some things about functions, what they are, what they can do, and some real-life analogies that hopefully will hit home and make it make sense to you. We're also then, probably in a second video, going to talk about writing and using our own functions. So how do we do these things? Now we've already had a little sneak peek at this when we did validation and display from forms. So we wrote a simple function, so we've got a little bit of the idea, but we're going to make them a lot more general purpose now. So we're going to spend some time on that, and then we're going to continue this discussion into the following week where we need to learn more about how functions work. So let's get started with the basic analogies to help you understand, and then we will move on from there. So the lazy professor analogy, how does this work, right? How do functions work, and how does that compare to this real world example? So the example here is, let's say that we have a professor, and this professor's been teaching a really long time, is kind of tired, kind of lazy, and finds it all very trying and very difficult to get started with class each week because he has a lot of little stuff to do, and he's really tired of doing it all himself, and he would really like some help to make this work better. So luckily, he has some eager students in his class. I don't know, maybe they want to butter him up to get a better grade, but somehow they seem eager to help. So this is a useful thing for the professor. So what does he do about this? Well, the professor needs to hire helpers to do certain tasks. So the first thing he does is assign which student's going to do which task, and they have a little discussion about what he expects. So it might look like something like this. So Susie's job is going to be getting the snacks, and when the professor wants his snacks, he's going to tap Susie on the shoulder, or he's going to nod to Susie. I mean, whatever it is, he can just say to her, "Hey, I'm ready for my snacks." And Susie's going to go to the vending machine on this floor and get some Fritos, go to the vending machine on the third floor, get some Pepsi, and after eating those Fritos, he's going to need some breath mints, so going to go to the bookstore on the first floor and get some mints. So that's Susie's job, and that is getting the snacks. Francisco is going to be in charge of getting the markers, and he is going to go to the office, let's say the professor's office, and grab a box of colored markers that are on the whiteboard and bring them back. Yuka is going to write on the board, so her job is write today's date and the name of the lesson that the professor is going to cover. Then John has one task, and that is closing the door, and then so when the professor wants that done, he can tap John on the shoulder or nod to him or say close the door. John's going to get up and go and close the classroom door. So that's the first thing that we have to do, is figure out which tasks need to be done, who's going to do them, and then have a little description of what's going on with that, right? What does that task involve? So that's a great start, right? That's a great start to figuring out these helpers. But we want to get a little more specific, because in addition to the description, there's also this kind of contract thing, and that is, what exactly do you need to start your task, and what exactly do you have at the end of your task that the professor needs, right? So we're going to talk a little more specifically about the contract. The description's a start, but what's the rest of the contract? So let's look at that briefly. So the task is described here, and then we're also going to talk about what does the student get, right? What does the student need to receive? Think about it this way. The student is sitting there with a hand outstretched, Susie is, because she's not going to start her task until she is handed what, in this case, handed some money. Susie's not spending her own money on the professor's snacks, right? So she's going to stand there with an open hand, and the professor has to tap her on the shoulder, but also give her some money, right? So no money, no task. So that is the input, right? The students get that as the student, Susie in this case, gets that as an input to her process, right? That's in her inbox. Then when she is done getting the snacks, what does she give back? Well, she gives back the snacks, right? That's part of her task is she's going to run around and do these things, but it's not for no reason. It's because the professor wants the snacks. So in her outbox, when she's done, she's going to place the snacks. And then when the professor, when she taps the professor on the shoulder to say, hey, I'm done, then the professor can retrieve those snacks from the outbox. So it's important for us to look at if there are things that go into the inbox and into the outbox for each of these tasks. Now notice Francisco is going to get the markers. He doesn't need anything to start his task, so there's no inbox for Francisco. He doesn't need to sit there with an outstretched hand. Instead, the professor taps Francisco, and then Francisco's going to run and go grab the stuff, and he's going to bring back the markers and put it in his outbox, and the professor can grab them there. What about Yuka? Her job is writing on the board. Well, she needs the lesson title because she can get today's date just fine, but she doesn't know the lesson title necessarily. So the professor has to tap her on the shoulder, and then she's waiting for a little piece of paper that says, what is the lesson title for today? When she's done, though, she has nothing back to put in her outbox, right? Because she's finished writing on the board. There's no other materials that she needs to provide back. Next and last, John, his job is close the door, and notice he doesn't need anything to get started with his task, nor does he have anything to put in an outbox afterwards. So John has sort of no inbox and no outbox, or an empty inbox and empty outbox in this case. So the professor taps John, John closes the door, and everything's complete, right? There's nothing else. So these are kind of important little details to get ironed out. What are you supposed to do? What do you need to get started with your task? And what do you have as a result of your task? All of these are going to turn into very specific things within a function once we move more toward the code idea. Now, there are a bunch of more details that are here in the slides. These were created for another class that's a little more advanced, but I'm going to go to each slide and talk just briefly, but you can pause them if you want to read in more detail. So one of the things that we should be careful of is not to confuse the handing over of stuff with valid work. For instance, Yuka doesn't give anything back. It doesn't mean she didn't do any work. John didn't get anything, nor did he give anything back, but that doesn't mean he didn't do work. So don't be confusing the idea that you have to pass something in or out in order to call it valid work. The other thing is, the contract is clear about what comes in and what goes out to each function, but how they are done is unimportant to the professor, because each function, when we move to that realm, is going to be completely independent, and each student here is independent as well. For instance, Susie might decide to take the stairs, she might take the elevator, I don't know, she might whistle a little song while she is working. That's fine, like the professor doesn't really care about any of this. Even the order in which she gets those, goes and gets those snacks is completely unimportant. The important thing is she has fulfilled her contract. She's completed the task, fulfilled her contract, and nobody really cares how she does it, right? That's important. It's independent. All right, so that's stop and pause here if you want to read more carefully, but that's a quick synopsis, and then one more little bit. The other thing that we might want to see here is that Susie might say, wow, that's a lot of work. The other guys have an easy task. My task is kind of complicated, so I'm going to hire some other students to help me. So instead of me doing all the work, I'm going to have Dana get the Fritos, Lupe get the Pepsi, and Chris get the mints. Therefore, I'm going to be able to delegate those tasks and have all those things done, and then I can just manage, right? I can just manage those tasks. So that's great. But notice, if Susie decides to do that, it is of no consequence. The instructor doesn't care. In fact, he doesn't even have to know. This really isn't a big deal because, think about it, Susie is fulfilling her contract. So as long as she fulfills the contract, the professor's happy. If she hires other people to do some subcontracting work, great, that's perfectly good. In that case, she has her own contract with each of those people, right? Money goes to them, they bring the thing back, etc. So each one becomes another little subcontract with its own contracts, right? So that is just some important notes for us to think about before we move forward and get into the details of how we actually use functions, right? So we're going to talk about one more thing, and that is, what can your computer do? How many things can your computer do at one time? Well, it's a longer lecture, but in essence, the computer makes it look like it can do a whole bunch of things at the same time, but a lot of that is because the way it does multitasking, and that is each program gets a little bit of time, right? Let's say you're running a browser, it gets a little time to do what it needs, and then you're running Excel, doing some calculations in the background, Excel gets a little time. So multitasking can be done even without having multiple processors. But in truth, when you write simple programs, your computer is running it on one processor, and that processor is running exactly one thing at a time. Doing any more than that is actually kind of challenging. So the interesting thing about that is that when a function calls another function, the caller freezes and is on pause, and then the called function does its work. When it finishes, it's done, and then the caller becomes unfrozen to continue its work. So there's this constant thing about when you tag a function, when you tag a helper to do work, you freeze, the helper does its work, and then when the helper's done, you can unfreeze and continue your work. So that's kind of interesting. If we're in deep into a thing that we're going to look at in a minute, a call hierarchy, there can be a lot of functions, a lot of workers above us in the call hierarchy that are frozen, right? They're paused. So that will help set the stage for this next discussion. So now let's look at this in a slightly different light, right? And understand exactly the order in which things are going to happen, because we now understand clearly one thing can happen at a time. So if that's the case, we draw things in a call hierarchy, and that shows who calls whom. The professor calls get snacks. He calls get markers. He calls write on board, and he calls close the door. Right? So these are the helpers that the professor is aware of and is going to call. Now, we also knew Susie subcontracted some work, so we know that get snacks is going to call get Pepsi, get Fritos, and get mints. The lines here are really specific, right? The way that these things are connected are very specific. Get snacks does not call get markers, right? That's not its hierarchy. That's not its line. The professor and get markers have communication, right? Get markers does not talk to write on board. Write on board does not talk to close the door. It's all a very strict hierarchy of going back and forth. So technically, if we could watch this inside the computer, if we could watch what's called the stack and watch the order in which these things are calling, we would see this. Professor calls get snacks. Get snacks calls get Pepsi, and that comes back. Get snacks calls get Fritos, the Fritos come back. Get snacks calls get mints, the mints come back. Now all the snacks are assembled and returned to the professor. The professor calls get markers, that work is done, the markers come back. Professor calls write on board, that work gets done, the control comes back that taps the professor back on the shoulder. The professor calls close the door, when that finishes it comes back and the professor is done or can continue with the lecture, whatever he needs to do. So that is a super important thing to get in your brain, is that when you're working with these things, you can draw a call hierarchy and you know exactly who calls whom, and if you think about it carefully, you'll have a complete mental picture of exactly the order in which these things are called and how the control flow in this case, right? The professor hands off the activity to get snacks. The professor's frozen. This continues to do its work. Then this freezes while this does its work, activates, freezes while this does its work, etc. So you can have a whole mental picture of what's going on inside the computer with each of these movements. And that's described in the next slide. I'll pause there so you can pause it right now if you'd like and read the whole thing, but I'm going to move on. So that gives us a pretty good picture of how things work. A call hierarchy is really useful when you're getting started to make sure you're clear about who calls whom. It helps us kind of understand the order. It's not that you couldn't call one of them twice, but that you get the general idea of the order, and it gives you a good picture of what's happening inside the computer. Now we're going to move forward and talk about how we write and use our own functions, right? We're going to move from the analogy world into something a little more concrete in JavaScript, but that gets us started, right? That gives us an analogy that we can depend on and talk about. So thanks for watching this video. Continue on to the next one. We'll talk about how functions can be written in JavaScript, how we can use them as building blocks, and then we'll start building some cooler and bigger programs using what we learned there. So thanks for watching.